round each of these numbers as specified. So the first one is 5.695 times 10 to the power of 4, and that's to one significant figure. So to start with, I'm just going to look at the number in front of the 10 to the power of whatever it is. I'm just going to look at the 5.695 and I'm going to round that to one significant figure. So I'm going to write it out. 5.695. It's one significant figure, so I need to find the first significant figure, which is obviously the 5. That's the first one there, and highlight it. So it's either this number that's going to stay the same or go up. So it's going to stay as 5, or it's going to go up to 6. Now bang in the middle at the point where we start rounding would be 5.5. Now 5.695 is bigger than 5.5, it's about here. So that would round to 6. So I've done the significant figure part. Now I need to reintroduce the times to the 10 part. So we're going to have 6 times 10 to the power of 4. Use my place value table. Again, doesn't need headings. We've got 6 times 10 to the power of 4, so it's going to move 4 spaces in the place value table. 1, 2, 3, 4. The 6 is going to go there. The decimal point was there and it will not move. So I just need to fill in the zeros. So my answer is going to be 60,000 for the first one. Let's have a look at the next one. So the next one is the same number, so 5.695. So we're just looking at the bit before the 10 to the power of whatever. So just this bit to start with. And this time it's two significant figures. So the first significant figure was 5. The second significant figure is that 6. So let's highlight that. And it's this number that's either going to change or stay the same. So I've got it's either going to stay as 5.6 or it's going to go up to 5.7. Now bang in the middle would be 5.65. And I have to think, well, where would 5.695 go? Well, that's going to be bigger than 5.65. It's about here. So again, it's going to round up to 5.7. So let's bring back the 10 to the power of 4 now. So it's 5.7 times 10 to the power of 4. Get my place value table. And we've got 5.7 and it's moving 4 spaces in the place value table. 1, 2, 3, 4. So the 5 is going to go there and the 7 is going to go immediately after it. And I fill in the zeros until I get back to the decimal point. Remember, the decimal point never moves. So my answer for this one is 57,000. Part 3, we've got the same number. 5.695 times 10 to the 4, but this time it's 3 significant figures, so let's write it out. 5.695, and I need to identify the third significant figure. 5 would be the first, 6 is the second, and then 9 is the third. So it's this that's either going to stay the same or go up. So my number line, it's either going to stay as 5.69 or it's going to go up. Now the 9 obviously goes to 10, but we can't do that here. It's going to go from 69 to 79, I imagine. So it's going to be 69 to 70. So it's going to be 5.70 or just 5.7. Okay, I am going to put the 5.70 because it's not going to matter just at the moment. Bang in the middle would be 5.695, which is actually what this number is, Now when it's bang in the middle, we do say that it rounds up. It's closer to the one above. So we're going to have 5.70 or 5.7. We don't need that 0 on the end. Times 10 to the power of 4. Again, get my place value table. And it's 5.7. And you'll see it's very similar to the last one now. Times 10 to the power of 4, so 4 spaces. 1, 2, 3, 4. 5, 7, 0, 0, 0. So this one is again 57,000. Last question here, we've got 9.95 times 10 to the 4, so we've got 9.95 this time. 9.95, and we want it to two significant figures. So my first significant figure would be the 9, the second significant figure would be this second 9, so let's just highlight that. So, now this is where we are going to have to use our brains here, so it's either going to stay as 9.9, or it's going to go up. Now, that 9 needs to go up, so it's going to become 10.0, because we're adding 0.1 to it, so 10.0 or just 10. So bang in the middle would be 9.95. So think of it like if you'd get rid of the decimal place, you've got 99, and then 100 would be the next one up, and then in the middle would be 99.5. So where would 9.95 be? Again, it's bang in the middle, so it would automatically go up. So it's going to be rounding to 10. So it's going to be 10 times 10 to the power of 4. That would actually be 10 to the power of 5, because that's 10 to the power of 1 times 10 to the power of 4, so that's 10 times 10 times 10 times 10 times 10. So that's the 10 to the power of 4, that's times 10, so that's 10 to the power of 5, which is 1 with 5 zeros. 1, 2, 3, 4, 5 zeros. So the answer to the last one is actually 10,000. So with these, I'd round each bit first. So we've got 6.85. Let's just have a look at that to start with. 6.85, and we're estimating. When we estimate, we round to one significant figure. So the first significant figure is the 6. So I have to think, well, is this closer to 6 or 7? It's closer to 7, so I'm going to round that to 7. So that's going to become 7 times 10 to the power of 5. And the same with here, the 2.23. Is that closer to 2 or 3? Because we're looking again at the first significant figure. Well, it's closer to 2. So that would be 2 times 10 to the power of 4. And I can now tackle this like I normally would. So if I just bring it over here, I'm going to rearrange it because it's multiplication, which means it's commutative. I can do it in any order. And bring the numbers to the front, 7 times 2. And then I've got 10 times 4 times 10 times 5. 7 times 2 is 14. 10 to the power of 4 times 10 to the power of 5 is 10 to the power of 9, because you add the powers. That's not in standard form though. It needs to be a number between 1 and 10 here, so I'm going to divide by 10 here, which means that I need to counteract that because I need to make sure it's still the same value. So if I've divided by 10 there, I'm going to counteract that by times in this one by 10. 10 to the power of 9 times 10 would be 10 to the power of 10. So for this one, we've got 1.4 times 10 to the power of 10. And then this one here. So we've got the 3.85. Again, round to one significant figure. So is it closer to 3 or is it closer to 4? Well, here it's closer to 4. So that's going to be 4 times 10. Where shall I do it? Yeah, I'll do it here. 4 times 10 to the power of 9. And then we've also got 2.23, round to one significant figure. The first significant figure is the 2, so is it closer to 2 or 3? Well, it's closer to 2. So that's going to be divided by, I'm going to put this straight as a fraction is a division. So it's 2 times 10 to the power of 4. So now I think, well, I can divide both the top and the bottom by 2, because 4 divided by 2, let's have a look. If I divide by the top and bottom by 2, 4 divided by 2 is 2 times 10 to the power of 9. And then 2 divided by 2 is 1 times 10 to the power of 4. And I can also do divide by 10 to the power of 4 now, because I know that when I divide, I take away the powers. So I'm going to have 2 times, and then, so that's going to end up being 10 to the power of 5, because 9 take away 4 is 5, over 10 divided by 4, it's a 1 times 1. So I'm just going to be left with 2 times 10 to the power of 5.